Okay, now for this section, we're going to find the C from the C-score to probability. Okay, probability. So I expect basically percentages giving us a decimal. I expect the answers to be between 0 and 1. Okay, 0 point something. Now here, very, very interesting. We're gonna learn how to read the C-score. Our last homework, we learned how to get the C-score. Now, for us to know today we're going to learn how to use it. And then for us to know how to use it, I'm going to be using the table that I told you guys on the last section to ignore. Let me bring it up. Talking about this table. Okay. Our C-scores are going to be decimals up to 2 decimal places. Okay. Up to 2 decimal places. The first uh, part, it is right here. You guys might be like, well, all of these are up to 1 decimal place. Yes, all of these are up to 1 decimal place. The second decimal place comes right here. Okay. So for example, let's say I came and I told you guys a C-score. Let's just say we have a C-score of 0. I'm not going to use it in there. Let's say I have a C-score of 0.83. So the first part on the left, I'm going to look up to 0.8, which is right here. My second decimal place comes up here. So 0.83 will be 0.2967. Okay? This is how we're going to read this. So remember, on the left, I have up to the first decimal place. The top completes the second decimal place. So let's say I came and I asked you guys to do 2.69. So 2.6 on the left is right here. The 9 is right here. So they meet at 0.4964, right? 0.4964. Some of you might be even wondering, okay, Mr. Leonzo, so what would, let's go here. What will this one be? If you look on the left is 1.8. If you look on the top is a 0.04. So that gives me my decimal 1.84. Okay. Now, what does this mean? What does this percentages mean? Okay. Now, for that, let me switch to our notes. Let me switch to this right here. Our C-scores, the mean is right here in the center. So when I have a graph, I have a bell shape, normal distribution, right here in the center, that's where our mean is. If I go to the right, my C-score is going to be positive. If I go to the left, my C-score is going to be negative. Okay. So notice, just real quick, notice how my first example, I went to the left, so my C-score is negative. Go here, my example 2, I went to the right, my C-score is positive. Now here in this example, I have 2 C-scores that went to the right, so it's positive. And then here I have a negative and I have a positive. So first, let's focus on the symbol, positive or negative. Now, another thing, the table that we have, the table that I gave you guys, the one that I was showing you guys how to read the C-score, that tells us the region or the probability from the C-score to the mean. So here, for example, in the first example here, I'm gonna below are the standard normal distribution. Find the area of the shaded region using a C-score table. Write the answers with 4 decimal places. Okay, so here I have a negative 1.25. When I look at the C-scores, I don't have negatives. However, I can find 1.25. All my C-scores here are positive. So 1.25. So I find 1.2 here on the left, and then the 5 here, and they happen to be 0.3944. So my C-score of 1.25 is 0.3944. Okay, so now coming back to here, 0.3944, okay? Now that is the probability, the percentage between the C-score and the mean. So basically, that is, I'm going to do red, this section. Remember, it was 0.3944. Okay, now is that what I'm asking? No, right? I'm asking if you see the shaded region, I'm asking for this probability. One pretty cool thing about normal distribution. On the left is 50% of our data. On the right is 50% of our data. So that means these two regions have to add up to 50%. Let me call it X for right now, because I don't know what it is, right? Let me call it X for right now. Remember, the C-scored will always tell me the probability from the C value to the mean, so to the center. It always goes towards the center. Now, one thing, the way I'm going to solve for X here, I'm going to go X plus 0.3944 is equal to 0.5. Why 0.5? Because I said 50%. Remember, from the mean to the left or from the mean to the right, it's always 50% or 0.5. Okay, so now we know how to solve equations, right? Minus 0.3944 on each side. So I get that my X is equal to 0.1056. Write the answers with 4 decimal places. Good. Got it. Might be like, oh, why the negative? What does the negative have anything to do with my answer? No, it was just telling me that it went to the left of the mean. But I used the table. Okay. Let's take a look at the next example here. 1.1. Okay. Let me get my C-score. Remember the table that we have? So my C-score right now is 1.1. So I'm looking at this. 1.1. If I was to write that using 2 decimal places, 1.10, right? So 1.1 here and 0 here. So my probability is 0.3643. 0.3643. So 0.3643. That is this region because it's from the C-score to the center. I'll say, yeah, that is part of what I'm looking for, but I also want this part. But remember how I said that was 0.5, right? 50% is 0.5. So wouldn't the whole shaded region, I would just have to add those two numbers, 0.5 plus 0.3643. I'm just going to add those two numbers and it's going to give me, in my case, it's going to give me 0.8643. Nice. 0.8643. Not bad. Let's take a look at this one. Oh, I have two C-scores. 0.12. I'm not gonna show the screen of the table, but 0.12 gives me 0.0478. So I know this red region, because remember it's from the C-score to the mean. So that little space, 0.12, is 0.0478. Now let me change this to, let's say, green. I'm going to read 1.91. According to my table, 1.91 is 0.4719. So that means I'm going to do this in green. This in green is 0.4719. Okay, so I want you guys to think about this real quick. Think about this. The red part is this. The green part is from here all the way to the center. Now, how am I going to find the blue part, which is basically what I'm solving? How am I going to find the blue part? Shouldn't I go the green minus the red? So shouldn't I go 0.4719, which is the green part, minus 0.0478, which is the red part? Yes. And that's going to give me, according to my calculator, 0.4241. I need you guys to pay attention to the picture. What am I asking? Go back to like the first example. The information that it gave me, that I gave you, was this part, but you needed this part. So that's why we did 0.5 minus that. Looking at the second example, I gave you these two pieces, right? Because we knew this half was 0.5. This part was 0.3643. So the blue part was those two combined. So just add. Now here, I gave you, based on the C-scores, I gave you the probability of the red. I gave you the probability of the green. You got to ask yourself, what can I do with those probabilities to get what I'm looking for? In this case, this blue. I just went green minus red and gave me the blue. So let's take a look at this case. I have two C-scores there. The 2.14, according to our table, 2.14 gives me 0.4838. That negative just means it's to the left of the mean, which is fine. 0.4838. Remember, that is the probability from the C-score to the mean. So that is, let's see, this much. We use red now for this other 2.3. If I read my table, 2.3 is the same thing as 2.30. My probability that I get is 0.4893. And that is the distance between 2.3 and the mean, the center. So that. So in my case, what would I do to find the blue? Look, this is the blue. Might be like, well, just add those two numbers, right? 0.4838 plus 0.4893. Yes, I'm going to add those two numbers and it's going to give me 0.9731. That's it. Okay, let's take a look at how do we use this table. Suppose the scores X on the college entrance examination are normally distributed with a mean of 550 and a standard deviation of 100. So we have that this is the mean, the standard deviation. Round your answer to the nearest 10,000th if necessary. Okay, 10,000th. Okay, that sounds like the number 10,000. How many zeros is that? 4. So that means my answer should be rounded to 4 decimal places. That's all that this thing is saying. 4 decimal places. Okay, not a big deal. Find the probability that the student gets at most 523. So what it's saying is, so you have a normal distribution. The mean, so right here in the center, is 550. So 523 will be somewhere over here, right? It says at most, so that means 523 or less. So the area that I'm looking for is this area. Now, it would be nice if I knew my C-score, right? But I know how to figure out the C-scores. Remember, our C-score is the value that we're testing minus the average divided by the standard deviation. In our case, it's going to be 523 minus 550, all of this divided by 100. It's going to give me a negative number, and it makes sense, right? I move to the left of the average, so that's fine. I need to do 523 minus 550, divide this by 100, and gives me that my C-score is negative 0.27. Fine. Again, negative because I moved to the left of the center. Fine. Now using my table 0.27, right? I know how to use the table. 0.27, that is 0.1064. So 0.1064 is this area. So how would I find the blue area? Now remembered, when I use black, from the centered all the way to one side, all that together is 0.5. Remember? Remember I said that all this together was 0.5. So the way I will do this, I will go X, because I don't know what the blue area is, plus 0.1064. It's equal to 0.5. Sorry for my pen is writing really weird. I don't think I need to show you guys. You guys are in stats. I don't think I need to show you guys exactly how to solve for X, but in my case, it gives me 0.3936. For my answer, don't type in X equals, just type in 0.3936. Now for my next question, find the probability that a student gets between 500 and 630. Okay, so coming back, here's my normal distribution. Here in the center, the mean is 550. So I want to know between 500. Let me just say it's right here. I'm just interested it's to the left. And 630, it's right here, just to the right of the center. And let me highlight in blue what I'm solving for, all that, right? Okay. Using my first value, 500. My C distribution, my C scored is going to be 500 minus the mean, which is 550. And the standard deviation, we said it was 100. So that's going to give me a negative 0.5. Negative 0.5. Okay, negative, that means it's to the left of the center. Makes sense. 0.5. So when I look at my table, 0.5, that gives me 0.1915. 0.1915. Okay. Notice how that's part of my area. Cool. Let me find the other one. The other part. I'm going to use green for this case. The number of testing is 630, right? So 630 minus 550, which is the mean, divided by the standard deviation, it gives me a score of 0.8. According to my table, 0.8 gives me 0.2881. So 0.2881. So for the blue, shouldn't I just add the two areas that I found? Yes. And I'm going to say my answer here is going to be 0.4796. 0.4796. Let's take a look at two more examples. Below is a normal distribution with the mu, the average should be 25 and the standard deviation is 12. What is the area of the shaded region? Write the answers in two decimal places. Okay, I need to find two C-scores, 31 and 37. Remember how my mean is 25 and standard deviation is 12? So for my first C-score, I'm going to go 31 minus 25 over 12. And that's going to give me positive 0.5. Positive because it's to the right of the center. Makes sense. The other C-score, I'm going to use 37, right? So I'm going to go 37 minus 25 divided by 12. Now 37 minus 25 divided by 12 gives me 1, positive 1. It is to the right of the center, so it makes sense. Now, according to our table, I look for the probabilities on each C-score, 0.5. 0.5 tells me 0.1915. If I go to the C-score of 1.0, it's 0.3413. So 0.3413. Okay. For the red, I want us to point out, for the red, this is what I have. For the green, this is what I have. My shaded region, what I'm asking you guys to find is this. So what can I do with the red and the green to find the blue? In my case, let me just write 0.3413 minus 0.1915. You guys see that red area, the green area, the blue area? Then you have to go the green minus the red, and that gives you the blue. My case, right? So 0.3413 minus 0.1915. I get 0.1498. 1498. But very interesting part here though. Write the answers with 2 decimal places. So in this case, I'm gonna write 0.15. Okay. Let's take a look at one last example. Below is normal distribution. The mean is 22 and the standard deviation is 10. What is the area of the shaded region? Write the answers with 2 decimal places. So first I need to find 2 z-scores. 8. I want to compare my x, 8. So let me go 8. Let me write this with my hand so it doesn't. 8 minus 22 divided by 10. 8 minus 22 divided by 10 gives me a negative 1.4. My other z-scored, okay, now let me find the other z-scored. I'm going to use 36 for this. So I'm going to go 36. Let me see. So 36, because that's the number I'm testing, minus 22, because that's the mean, divided by the standard deviation, which in this case is 10. 36 minus 22 divided by 10, it gives me a 1.4. By coincidence, my z-scores are pretty similar. One of them is negative, one of them is positive. One of them is negative because it's to the left of the centered. One of them is positive because it's to the right of the centered. So when I look at 1.4, when I use my table and I look, what's this? The probability 1.4 gives me 0.4192. So 0.4192. When I hear 1.4 again, it's going to give me the same number, right? 0.4192. Now, one thing I want to leave clear. Don't expect on your homework to be the same number on both sides. Just a negative z-score and a positive z-score. By coincidence, we got that. Don't expect that all the time. Okay, so what is this on the left? I'm looking at the first one right here. It is from this line to the center, right? So my probability, let me see, hopefully my pen doesn't act weird. 0.4192. That is this area. Now from the other one, 0.4192 is this area. So shouldn't I just add them both? All right, for me to find a blue area, I'm just gonna go 0.4192. I'm gonna add them both. And it gives me 0. So this area, 0.8384. That's what my calculator gave me, 0.8384. But I know I have to answer in 2 decimal places. I have to run it to 2 decimal places because that's what it says here. Write the answer with 2 decimal places. So I'm going to round this to 0.84.